Okay guys, this is my first YouTube channel and I'll be teaching you physics, chemistry and mathematics, or maybe other subjects like biology. So the main topic we'll be studying today is waves. So what is a wave? That's the first thing you should be asking yourself about wave measurement. So we'll define a wave first. It is an easy definition that you should keep in mind because most of the time it should be coming maybe in any exam paper. So it's a disturbance that is transmitted from one point to another. It is simple as that. Just try to keep that in mind and you'll see. So there are things that you need to consider. For example, examples of waves. So I'm going to list them for you. This includes water waves, sound waves, electromagnetic waves, and light waves. Pretty sure there are even more, but these are the only good examples I can list for you as they will be easy to understand. As for electromagnetic waves, I'll be teaching it later on. So follow me guys and please don't forget to subscribe. We need to upgrade. We have two types of waves in short. There is transverse wave and longitudinal wave. So I'll start by explaining transverse wave first and I'll make a video for easy understanding. So transverse wave by definition, we are going to define. Transverse wave is a wave in which the vibration of the particle are right angle to the direction of the travel wave. So guys, this is a transverse wave. Keep that in mind. So as I have written here already, this is an amplitude. An amplitude can also be here. This can also be an amplitude. Even here it can be an amplitude, or even here. So don't forget guys, don't get confused between this. This is an amplitude. And when you look at this sign which I've written here, it is not at the center of a trough or crest. By the way, the things found on top, we call them the crest. And then the down one, we call them the trough. So on top, the crest, and the below ones, the trough. So two crests makes up what? A wavelength. So for example, this again is also a what? A crest. Yeah? This one is also a crest. So when you connect this crest here and this crest here, this line here, it will make up a wavelength. Don't forget that. This line here will make up a wavelength. Same here, when you connect this crest here and this crest here, this point here and this point here, when you connect these 2 points, they'll make up what? A wavelength. It's easy as that. Don't forget that. Again, you can even say this here is a trough. Here, as you can see here, it's a trough. Same here, again, it's also a what? A trough. When you connect this, it will also make up what? A wavelength. It's easy. Plus, don't forget, I said the symbol for wavelength is what? It's this. This is a symbol for wavelength. For amplitude, we do not talk about any symbol because it does not have a symbol. As for displacement here, let me just say displacement here. Displacement. So here, as I've written displacement is measured in what? In meters. In meters. This line here, which you are seeing, which is separating the crest and the trough, we call it the rest position. Yes, the rest position. That's what we call this line. So you should know how to understand this entire thing here for you to understand a bit more about transverse wave. Okay? It is simple and straightforward. Keep that in mind. As for the definition, I'll explain it later on. So continue watching the video and you see how it goes. It is easy as that. How to calculate, I'll show you. So let's get to the phases now. Phases are what complicate things in this kind of topic, but I'll explain it in a simple way that anyone can understand, okay? Okay then, we proceed. Transverse wave by definition is a wave in which vibration of the particle are parallel to the direction of the travel wave. So when you look at the parallel and the right angle, you can just exchange that and then the definition is set for both longitudinal and the transverse. Simple as that. So let me show you the diagrammatic form. So guys, let's go to longitudinal wave. Longitudinal wave. Alright guys, I'm bad at drawing, so just try to follow it ways. So what do you understand by the term compression? Matter of fact, I don't even need to ask you that definition. I'll just write it. Compression. Just by the term compression, you can hear that words compress, right? So when you look at this point here, we are looking at longitudinal. So compression, you can look at this and then say which one's compressing. You are going to mark this point here, by that I mean lines, and then here. So when you get this, again this, this is compression. So when you look at the longitudinal wave, the compression part, it is the one that is shrinking. And then there's this other term which they call rarefaction. Rarefaction. Not refraction, but rarefaction. Different from what? From compression. Yes, from compression. Yeah, I'm bad at pronunciation, so just try to follow still. So we are going to mark this point here, and then again this point here. And then I'm going to do this for easy understanding. Yeah. So when we were looking at this transverse wave, we said two crests make up what? Make up one wavelength. But here we are going to say two compression makes up one wavelength. For example, this here is a compression, and then same here, this one is also a compression. When you connect this makes up what? A wavelength. This is a symbol for wavelength, which I haven't forgotten, but just an emphasis, I guess. And then I can again get this point here, and then again this point here. And then this again is also a what? A wavelength. Pretty sure you must be asking that, why is this guy repeating the same thing? You need to understand this, because if you don't understand this, then the entire wave, it is useless for you. Okay? Again, you can get this, and then you can match it. This is also what? A wavelength. Simple. Okay, these are the only things I wanted to say, but if you want to know where the amplitude is found for the longitudinal wave, then just know that this is the part for what? For rarefaction here. So this is the amplitude. You can even mark it here, amplitude. But do you know the book I use for this kind of topic? I use Progress book. It is one of my favorite books. Pretty sure you guys, you like pamphlets and all this kind of stuff, but me, I prefer textbook. Even though they have a lot of notes, they are not summarized. That can even explain better, I'm telling you. So follow you guys. It is easy. So I'm done explaining about this. Now I'll just go straight to the definition. If you're not interested, then you can just get a pamphlet and then start reading the definition now. Because pretty sure the only thing you wanted to watch this video for, it is for just understanding, and that's so. That is what I need to expect from you guys since you want to pass the grade 12 exam. Because this is just grade 11 week. I'll teach more about half-life and all this kind of stuff later on. So just try to follow and subscribe.
So I'll just define real quick. We'll start with amplitude of the wave is the maximum displacement of the particle from its resting position. Units meter symbol A. Okay, we proceed. And then we have wavelength. It is the maximum distance at which the result will repeat itself. Units meter symbol lambda. We proceed again. Follow please. Points in a phase, as I have explained, you can just read this statement here as points on a single periodic wave that have the same displacement and move in the same direction are in a phase. So guys, this is simple and straightforward, and just by looking at this you can again understand more about phases. This is under wave motion. It is easy guys. Next one, period, is the time taken for one complete vibration of a particle or wave to complete. This is also in oscillation. Frequency of a wave is the number of complete waves produced per second. It is the number of waves made in 1 second. Symbol, it is F. Units in periodicity, hertz. Okay, we continue. Hope this is making sense. Speed of a wave is the distance traveled by the wave in 1 second. This is just for speed. Symbol V, SI unit in meters per second. By the way, speed is same as velocity. Keep that in mind. Okay guys, thanks for watching this video. Now guess I'll be ending the video. See you on my next video if you have subscribed.